right, class, this video is going to cover section 8.3, which is about estimating population proportions. We just finished looking at how to estimate population means. Now we're going to take a look at population proportions. So, the margin of error for a population proportion, okay, is going to be 1.96. Remember, that's how many standard deviations we need to have the middle 95% of data, times p hat. This is our sample proportion. Sample proportion times 1 minus p hat, which it's important to remember that this should add up to 1, p hat and 1 minus p hat, right? So this is the probability of an event occurring. This is the probability of an event not occurring. Divided by the square root of n, where n is our sample size. So our confidence interval, just like when we were working with population means, we're going to have our sample proportion in the middle, and we're going to subtract and add our margin of error in order to create a confidence interval. So let's take a look at this example. So I know I'm working with a population proportion because we have a percentage here. So for this problem, the Nielsen ratings for television use a random sample of households. A Nielsen survey results in an estimate that a Women's World Cup soccer game had 72.3% of the entire viewing audience. So let's assume that this sample consists of 5,000 randomly selected households. I want to find the margin of error and the 95% confidence interval for this estimate. So I'm going to calculate my new error, and since I'm working with proportions, I know to work with the equation of 1.96 times the square root of p hat, which is not 72.3%, we need to write that as a decimal, so 0.723 times 1 minus p hat, which is 0.723, over our sample size, which is n, so 5,000. And I would find, if I plug this in my calculator, making sure to keep track of PEMDAS, an error bound of 0.012. So in order to construct my confidence interval, I'm going to take p hat minus my error is less than our true population proportion, and our true population proportion is less than p hat plus my error. So I'm going to take 0.723 minus our error, and 0.723 plus our error. So I have a 95% confidence interval that P is between 0.711 and 0.735. Okay? So we could convert these back to percentages. So I am 95% confident that the true population proportion watching the Women's World Cup soccer game was between 71.1% and 73.5% of the population. All right, in this next example, in a survey of 50 randomly selected individuals at a large company, 38 said they like driving a car to work every day. Assuming that the sample consists of 50 randomly selected individuals, we want to find the margin of error and the 95% confidence interval for this estimate. So I know my N. The problem is, what is my P hat? Well, I'm not given my P hat, but I can calculate it because 38 out of the 50 said they like driving their car to work every day. So I'm interested in the population. So what percentage say they like driving a car to work every day? I am not part of that population. So the people who like driving their car to work, 38 divided by 50, that gives you 0.76. So 76% of this company. Okay? So I want to find the 95% confidence interval. So I'm going to take my error. That was supposed to be an E, everybody. Here we go. Error is 1.96 times the square root of p hat times 1 minus p hat over our population size, which is 50. So I have an error of 0.12. So I'm going to construct my confidence interval. That's going to be p hat minus my error bound. So I would get 0.64 is less than our true population proportion, which is less than 0.76 plus our error bound, so 0.84. So between 64% and 84% of our population enjoy wearing to work today, and I'm 95% confident about that. Now, just as before when we were working with sample means, how you could choose your sample size to pick how large your error was, you can do the same thing for population proportions. And this equation is super easy, right? My sample size, n, is just 1 over my desired error bound squared. Okay? So you're going to need to know when to use how to determine the correct sample size for population proportions and for population means, because they are two different equations. But this is the one for population proportions. So let's say we planned a survey to estimate the proportion of students on your campus who carry a cell phone regularly. I can tell you right now, it's 100%. 100% of students carry their phone all the time. So how many students should be in the sample if we want a 95% confidence interval with a margin of error no more than 4 percentage points? So the first thing I need to do is I need to convert this error into a decimal. So 4 percentage points would be 0.04. So in order to calculate what size I should sample, I'm going to take n equals 1 over e squared, which in this case is 1 over 0.04, and I'm going to put this in parentheses because sometimes it helps in your calculator, squared, and that's going to give me 625. So in order to conduct a survey at a 95% confidence level with a margin of error of no more than 4 percentage points, I would need to survey at least 625 students.